Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see problems on nodal analysis. In this video, first we will see the procedure for nodal analysis, and then we will see problems on nodal analysis. And in this video we will see problems having only voltage sources. Right, we will see two problems in this video, and this concept is very important concept for all electronics and communication students, and this is very basic information that you have to know before solving any circuits. Right, so first we will start with the procedure of nodal analysis. So coming to procedure, these are the points which you have to be clear before solving any nodal analysis problem, right? So if a circuit is given, first thing what you have to do is you have to find out the nodes. The circuit can be given with label of nodes or without the label. So what you have to do is you have to mention the nodes, you have to find out the nodes, and you have to take one node as a reference node, and for that reference node you have to apply KCL. Say for example you have followed three nodes A, B and C, then you have to apply KCL for all these nodes, on this particular circuit. And while applying KCL, you have to follow this particular condition. That is, you will write an expression, you will write an equation, same like mesh analysis, where mesh analysis you followed a different procedure to write the equation. Whereas here, you have to first consider whether it is a voltage sources or current sources, right? So if it is only voltage sources, then you have to consider this condition. That is, whenever you start from any particular node, say for example, if you're going to consider this as a node VA, you consider this as a higher potential, right? And you see the opposite end, the voltage source, whether it is plus or minus. So if it is plus, then it will be higher potential. If it is minus, it will be lower potential. Right? So if it is from higher potential to higher potential like this, if it is from higher potential to higher potential, then you have to use negative sign. If you are seeing voltage source like this, negative to positive, so from here always you consider the node as higher potential. So it is from higher potential to lower potential. So in this case it will be positive, right? Whereas for current sources, whenever a current source is given like this, that is whenever it is approaching this particular node, then it has to give a negative sign. And whenever the current source is given like this, that is it is moving away from node, then it is given as positive. So you have to be very clear with this. So if it is higher potential to higher potential, you have to give negative sign. If it is higher potential to lower potential, you have to give a positive sign. And if it is towards node, for current sources it is negative, and if it is away from node it is positive, right? And once you form the equation, right, you will simplify the equation and you will get equation 1 and equation 2, and depending upon the circuit you will get 2 or 3 equations, right? And those equations can be solved using any method. You can use calculator, or you can use Cramer's rules, or you can use any method, even manual calculation method, right? Already we have seen problem using Cramer's rule for mesh analysis. You can also refer that video to understand the Cramer's rule, right? And once you find out the voltages V1 and V2, right, and you can able to find out the branch currents across each resistors, right? So this is the procedure for nodal analysis, right? So any problem, first thing you have to find out the nodes, you have to consider that as a reference node, and you have to apply KCL. And when you are applying KCL, you have to follow this procedure. And once you found out the voltages, unknown voltages, you can able to calculate the current across all the branches, right? So with this we will start a problem, right? Consider this problem, right, where you have two voltage sources here. So now I am going to write the equation for it, so that you can able to understand. So now first thing what you have to do is you have to identify the node, right? So I am going to identify this particular node, whereas you can see here, this is the node where all the junctions meets, right? So I consider this node, that is like you can see this voltage source and this voltage source and this resistor, everything connected connects at this particular point. I consider this as a V1, this as a reference node, right? And now I'm going to apply KCL. So while applying KCL, I already said whenever you are considering any particular node, that is considered as a higher potential, correct? So this is considered higher potential, and now if you see this voltage source, this is higher potential, plus and minus is given. So this is higher potential, right? So this point is higher potential. So how will I write? It is V1 minus 42 divided by 8. It is similarly V by R. It is similarly V by R concept, where you will have two voltages here. One is V1, another one is 42. So I am subtracting it because here it is from higher potential to higher potential and divided by this particular resistor value. And if you take this particular branch, this branch, see there is no voltage. So it is V1 divided by 4. And similarly, if you consider this particular branch, so initially you have to put these signs like 3 directions, right? So you consider this one branch, this is one branch, and this is one branch. And now in third branch, you can see it is V1. You can see this is higher potential, and you can see here it is lower potential. So I have to put it as plus 10 divided by 6 equal to 0, right? Now if you take LCM and if you simplify, you will get the voltage V1 value. You will get some value. You will get some value here, right? Some 6.6 something you will get. I will show that in next slide. So you will get some value here. So we have taken only one node and we have found it out V1, right? Now what is the question they have given? They have asked you how to find out current. That is, you have to find out current across all the branches. So you have to find out what is the current flowing in this branch, what is the current flowing in this branch, and what is the current flowing in this branch. You have already written the equations for it. So you have to find out for I8 ohm. For I8 ohm, I8 ohm is this branch, right? So you will just supply, you have to take this, consider this expression alone, and you have already find out the V1 voltage. So if you substitute the V1 voltage here, 6.6 something, right, minus 42 divided by 8, you will get this current. Similarly for this one, you take this branch, is simply V1 divided by 4. And similarly for this particular branch, it is V1 plus 10 divided by 6. So you substitute the value of V1, you will find out the current across this 6 ohm resistor. This is the basic procedure for any node analysis problem, right? We call this as node analysis or nodal analysis, right? And you can see here whatever I said. I'm taking V1 as reference node, and you can see V1 minus 42 divided by 8, V1 divided by 4, and V1 plus 10. You are taking LCM and you are simplifying it so that you are obtaining the value as V is equal to 6.61, right? And now we need to find out the current across this resistor. So current across this resistor, I am supplying V1 here, 6.61 minus 42 divided by 8, right? I am getting a negative sign, you can neglect the negative sign, right? And similarly, current across this 6 ohm. 6 ohm is where this expression V1 plus 10 plus 6. So I am just applying V1 6.6 and then I am finding out I6 current. Similarly for this branch, it is I4 is equal to 6.61 divided by 4. So that you will get it, right? So you got to find out the current across all the branches. For that, you got to find out the voltage of that particular node, right? So if you follow the procedure, then you can easily solve any problem, right? Now we will see another problem here. So consider this particular problem where now we are going to consider find out the current flowing across all the resistors. Now if you take here, you can see the junctions. How many junctions you have? You have 2 junctions. Like in the question itself, they are given as A and B, right? So you can see here, if there is 3 meshes, then you will have 2 nodes, right? It will be like one lesser than any particular mesh. Say for example, in previous problem we have 2 meshes, so you consider only 1 node, whereas here we have 3 meshes, so we consider only 2 nodes. right? So it is A and B. Now you follow the same procedure. If you take A, you consider this branch, and this branch. If you take B, you consider this branch, and this branch. And right, like that, you will find out what is the expression for this particular node and what is the expression for this particular node. And you have to simplify the equation, and you will find out the V1 and V2, right? Now that is VA and VB. And what after finding out VA, VB, once again you have to use the same expression to find out the current across all the resistors, right? I'll just write the expression alone and I'll explain the complete problem. So now you take first VA, right? Applying KCL at VA, applying KCL at node VA. Now what will happen? VA I consider it as higher potential. So here it is also higher potential. So VA minus 4 divided by 5, correct? Plus this point VA divided by 15. There is no other voltages, right? So and if you consider this one, this point is VA minus VB, VA minus VB divided by 10, right? So this is expression 1. You simplify this and you will obtain a proper equation. Similarly for B, now what I will do, I will take I4, I5 and I6, right? So you know that why is that you are adding here, whenever you apply KCL, sum of current is equal to 0. I1 plus I2 plus I3 is equal to 0. So you can see here this I1, I2, I3. I am considering it as I1, I2 and I3, right? So that is equal to 0. Similarly, if you consider this one, this branch, that is node B, it is I4 plus I5 plus I6. That is equal to 0. Now how will you write the expression here? If you see here, it's VB minus VA. VB minus VA, because I have already said this is also higher potential, this is also higher potential. Any node is considered as a higher potential. Divided by 10 plus VB divided by 8. VB divided by 8. And if you see here, this is higher potential and this is also higher potential. So it is VB minus 6 divided by 12. This is expression 2, right? So you can see here the same equation, right, for this particular problem, the same expression whatever I solved, right? So you can see here VA minus 4 divided by 5 and VA minus 0, there is no other voltage, so VA by 15. So VA minus VB divided by 10, right? And you simplify this, you will obtain this particular expression. Similarly, this particular node VB, you can see here VB minus VA divided by 10, and similarly VB divided by 8, and similarly VB minus 6 divided by 12. And if you solve, you will get this expression. So now you have equation 1 and equation 2. You can solve equation 1, equation 2 using your calci. I have already explained how to solve using calculator. So after that, you will obtain VA value as 2.878 and VB as 2.555, right? Now you need to find out branches across all the resistors. Now you have find out what is VA and what is VB, right? Now for the current to find out across 5 ohm, what you have to do, you have to find out this value. VA, you have to substitute VA value minus 4 divided by 5, you will get the current across this particular resistor, right? Similarly, if you want to find out the current across this particular resistor, VA divided by 15, right? You have to substitute the VA value and divided by 15. Similarly, for this one, you have to mention VA minus VB divided by 10, right? And similarly, if you want to find out this resistor 8, then you have to use this particular formula. And you have to find out this particular resistor, then you have to use this particular expression. You can see here, that is what we have done here. After finding out VA and VB, right, the current across 5 ohm resistor, VA minus 4, the corresponding expression, we are just substituting the VA and VB value and finding out the current across all these resistors, right? So today what we have seen is we have seen problems on node analysis, and before that I have explained you what is the procedure that has to be followed for nodal analysis. I believe this video will be useful for you. Thank you, my dear students.